what's up? Welcome back, guys. Today we're talking about a video that I shot all the way back on October 2nd of 2016. Yeah, it was a long time ago. I still have the footage though, which is awesome. Now the reason I still have the footage is because I didn't want to release anything of the way I built this until it was fully tested and everything like that. And what this video is about is a thermostat on a 2005 Jeep Liberty CRD I had. Now, they made these Jeeps for 2 years. It was 2005, 2006. Now, what it was an inline four-cylinder turbo diesel made by VM Motori that was in those. They got kind of squashed out by EPA regulations, stuff like that. So they only made them for 2 years. Awesome little torquey engines, but they had a lot of weak points to these things. Now, one of the weak points was the thermostat in them. Thermostat was only rated for 176 degrees Fahrenheit. Now, anybody that knows anything about diesels run better. You get more power out of them, and you get better miles per gallon out of them the hotter they run. So, I was out on a mission in order to find a thermostat that was going to be hotter, make it run hotter. Now, I stumbled across this one online this guy makes. It is a fully CNC'd version of it. It used a Hemi engine, any Chrysler Hemi, thermostat, and I believe it was rated for like 200 or 204, 205 degrees Fahrenheit. I can't remember exactly what it was. But that's about the right temperature that you would want these to run at. Now, it was a decently made piece. It looked good. It performed. I assume it performed well. It was designed off of the original piece. It just basically so it's fully CNC'd, but the measurements were just different. But so there's no reason it shouldn't have worked. But anyways, in order to get that thing, it was basically $500 shipped to your door. And the thing is there is no way at that point in my life that I was going to be able to afford a thermostat for $500. There's literally no way. I don't think I could have done that. So what I had more time than I had money. And I had tools at my disposal. So I set out on a mission. I was like, man, I could probably build one of those. It's just a thermostat. I could probably do that. So I set out on a mission to do that and wanted it to work like OE functionality and be reliable. So this video, what we're covering here, is to show you guys the full breakdown of exactly how I did it. And it all started with this. Let's get right into it. And away we go. So basically, after I discounted that original aftermarket thermostat that was CNC made and all that, I totally wrote that off as not even an option because I wasn't going to drop that kind of money on a thermostat. So what I did was I started getting a hold of people on different Facebook pages and stuff like that and getting junk thermostats. Thing is, people obviously wouldn't want a junk thermostat laying around, and they go out so often that they were plentiful, A lot of people had them laying around. So I got people, some of them I paid them a little bit of money for them. Some people just had me cover shipping and they'd ship it right to my door, which was great. So then came the experimentation part. Time to start cutting it apart and see what we got. So looking at it, I figured out I could disassemble it from the factory on the top. That it was two pieces put together, and it was the top part went down inside the bottom part, and it was like a machine had crimped it. So there was a small flange of aluminum that crimped around the top lip part of it. So what I did was I went ahead and bought a mini belt sander from Harbor Freight. This is a 1/2-inch one. The one I used on this was a 3/8 one, which is, obviously even smaller. And then what you see here, that top lip that was just crimped barely around that top piece that fit inside of it, I went ahead and took this and I just ever so gently ground it down until it was basically nothing, okay? And then I could pull it apart. So buzz that part off, took a little dead blow hammer, kind of tapped it apart, pulled it apart, and then, so the O-ring was on there and it was perfectly fine. There was no damage whatsoever to the O-ring. It went on that flat surface right there and just sealed to the bottom housing. So I took all the measurements of this cartridge that was inside this unit. So the housing was bad. The housing wasn't bad. The cartridge was. I went to, I believe it was O'Reilly's, and they had a catalog of thermostats in there. So what I did was I grabbed my calipers and I grabbed all the old thermostat stuff. I went in there, and inside this catalog, it told all the internal measurements of these thermostat cartridges and all this stuff. So I set to work, started measuring everything I could about it, and I ended up finding one that matched it really, really closely. So here it is. It was this Murray Temperature Control Plus 34998 part number. You just type that into Google and AutoZone pops up with a part that matches it. O'Reilly, everybody. A lot of people have it, and I found it anywhere, I think, from $14 to $22 for this cartridge. Well, it's a cartridge with the top cap. So let's go ahead and crack it open. You'll see right here. Now, this was the highest temperature one that they had for this. Well, it's just this part, but they gave you a bunch of different temperatures for some certain car. I can't remember the car, but this was a 198 degree unit. So all the measurements were real close. They were I don't need the top part. I wasn't going to modify the original housing. I probably could have and made that one work with it, but I figured I would try to get that cartridge to fit in the original VM Motori top cap. So you can see it's really close. Now the Jeep one has a jiggle pin, and a jiggle pin's that extra little brass piece in the top. What that does is that lets air escape. Air will escape, but when water gets when water goes to it, it'll plug the hole with a little ball bearing. Some people will just put they'll drill a hole and put a little cotter pin through it or something. There's all sorts of ways of doing it. See how close it was to fitting? So I realized I was going to have to make a little adapter for that. Took a whole bunch of measurements, man. This was originally a piece of stainless steel angle iron. And I used a plasma cutter, yeah. That's why it looks so rough, man, because put it on the mill and milled it down. So those edges were pretty close to and the other side, see those little grooves, how they all fit together? I just ground the other side. I used a cutoff wheel on a grinder and just ground a little slot in it on the other side, and the other side that rib goes up. So I machined down the center in between those two little grooves. And that was in order to keep it in its home position and keep it from floating around and popping out of that housing.
Peg in it that goes to the top of this.
So the little peg goes in that hole in the middle. See, just like that. Put that in. And then we take our little adapter that we made, a little adapter ring. Push down, turn it into position just like that. I remember that thing had a lot of spring pressure compared to the factory CRD unit, but I was able to make it work. See, it fits perfect.
What I did was I just took measurements.
See, I just took all the measurements off of this, and it took a little bit of planning, some design and drawing on paper and stuff, you know, in order to make it all fit. But as you can see, it fit nicely. And those little edges in there retained it perfectly. So if I put my mouth on the end of that and blow into it, there's literally no air that could escape past that top sealing flange. It was a perfect fit, which is crazy. So from the factory, this is a 2-stage thermostat. See that bottom disc right there? The bottom disc, it seals off inside the bottom. That little line that goes out the bottom, that's the bypass. So it seals that off. So I knew I was going to have to make it match the factory one.
Fluid through the orifice on the bottom. And then when it gets to a certain temperature, it plugs it off with.
Yeah, so as it heats up, that whole insert moves, both pieces at one time. It opens the top and closes the bottom. So that other thermostat, it's a little bit shorter throw to it, so I knew I had to make an adapter to seal off the bottom at the proper temperature. So what I did was I took that top housing, just like you see it right here, and I put it in a pot of water. I had a thermometer in the water and everything. I heated that water up to 200 degrees. And then while it was in the pot, I took my caliper, just as you see here, and I measured the throw on it, okay, at 200 degrees. And then that is how I determined the thickness of this spacer right here. So I wanted it to be a press fit. So the inside, it's a super tight fit into the bottom of that bottom housing right behind us. And as you can see, the lip right there. Oh, I forgot to zero out my caliper here. Rookie mistake. Here we go. 270 thousandths. I don't remember the ID. So the ID doesn't really matter, because look at the inner diameter of that little tube that goes out the bottom of that. It looks big inside the bottom of the bowl, but look at the actual diameter of that tube. It's never going to flow more than that. So I just kind of eyeballed it, you know. What mattered is the OD in order to make it a press fit.